Hi everyone, this is Lahari, studying in Sri Venkateshwara College of Engineering. Today I am going to discuss about the overview assumption in fault-based testing. Introducing about the topic. Fault-based testing is a popular approach used in software testing. It involves intentionally introducing faults or errors into the system to evaluate its performance under different conditions. The objective of fault-based testing is to identify and fix potential issues before they become major problems that can affect the quality of the software products. Overview and fault-based testing. Engineers study failures to understand how to prevent similar failures in the future. For example, the failure of Tacoma Narrow Bridges in 1940 led to new understanding of oscillation in high wind and to introduce of analysis to predict and prevent such disastrous oscillation in subsequent bridge design. The causes of an airline crash are likewise extensively studied, and when traced to a structural failure, they frequently result in a directive to apply diagnostic tests to all the aircraft considering potential vulnerable to similar failures. Experiencing with common software failures sometimes leads to improvements in design methods and programming languages. For example, the main purpose of an automatic memory management in Java is not to spare the programmers the trouble of releasing unused memory, but to prevent the programmers from making the kind of memory management errors that frequently occurs in C or C++. The frequently occur errors may be dangling pointers, redundant deallocation, and memory leaks. Of course, not all programmer errors fall into the classes that can be prevented or statistically detected using better performing languages. Some faults must be detected through testing, and there too we can use knowledge about common faults to be more effective. The basic concept of fault-based testing is to select the test cases that would distinguish the program under test from alternative programs that contain hypothetical faults. Fault seeding can also be used to evaluate the thoroughness of a test suite or for selecting test cases to augment a test suite or to estimate the number of faults in a program. Next topic is assumptions in fault-based testing. The effectiveness of the fault-based testing depends on the quality of the fault module and on some basic assumptions about the relation of the seeded faults to the faults that might actually be present. In practice, the seeded faults are small synthetic challenges like replacing one variable reference by another in an expression or changing a comparison from less than to less than equal to. We may hypothesize the are representative of faults actually present in the program. If the program under test have an actual fault, we may hypothesize that it differs from another corrected program by only a small textual change. If so, then we need merely distinguish the program from all such small variants to ensure detection of small such faults. This is known as competent programmer hypothesis, an assumption that the programmer under test is close to a correct program. Fault-based testing can guarantee fault detection only if the competent programmer's hypothesis and the coupling effect hypothesis holds. But the guarantees are more than we expect from other approaches to designing or evaluating the test suits, including the structural or functional test adequacy criteria. Fault-based testing techniques can be useful even if we decline to take the leap of faith required to fully accept their underlying assumptions. What is essential is to recognize the dependency of these techniques and any interferences about software quality based on fault-based testing on the quality of the fault model. This also implies that developing better fault modules based on hard data about real faults rather than guesses is a good investment of effort. Conclusion for the topic is fault-based testing is a powerful tool for improving the quality and reliability of software application by deliberatively introducing the faults into the system and testing its ability to detect and handle them. Developers can identify and fix the potential issues before they become more critical problems. By following the practices and establishing the guidelines, developers can maximize the effectiveness of fault-based testing and ensure that their application meet the highest standards of quality and reliability. Hope you all clear with the concept of overview, assumptions and fault-based testing. Thank you.